Everybody, I'm ready. So I think it's the last one, so it's quick. Get it over with. Yeah. Okay.
The last one.
Sorry.
I'll make it quicker.
Alright, so yeah, ours is SpaceGloVe challenge. That's what we're doing. We're doing spacecraft gesture and voice commanding control stuff. Slide. Our introduction, it's about mainly gesture control, application of existing technologies in creative ways to achieve goals. Next slide. Our scenario is we're supporting the NASA goal of human manned exploration of Mars. We've got a human on Mars, hypothetically already, and he's controlling a robotic miner, and he's doing that remotely. This is bringing down the cost of space access by collecting resources, building structures, and collecting stuff in situ. We're going to be messing around with GUIs, brain scanners, robot controls, and cameras. Slide. Okay, that's not very interesting, so there's the next one. Right, so I want to show you what we're doing. We've been doing the SpaceGloVe. This is the SpaceGloVe. He's got one here to show you. He's putting it on and it's controlling the GUI. Now we've got an interactive GUI here. It's using sensors on the Sensorduino Android app. Slide. This isn't our app. We had a big go at doing it. The Bluetooth was terrible to use. We managed to get a workaround. I'm just using this. Just moved on. That's fine. We've got accelerometer data coming out and orientation. What it's doing at the moment is just rotating. We'd like to have it zooming in, selecting things, and clicking on things. Yeah, but that's future work. Slide. Okay, this is the interface. There's an earlier iteration on the right. This is the later one. Nice picture in the background. Yeah, click through.
Okay, so I think the idea here is if you're an astronaut, if it's touchless, it can be beneficial in a lot of ways, especially if you're floating around in your Jeep. So the idea is you can manipulate a globe with the wrist like that. So imagine you could set a waypoint for, say, where you want to explore. I know it's Earth on there, but you can imagine it with Mars. So you set a waypoint on there, and say you've got a robot down on Mars that you want to control, right? So we zoom in there, and then by doing that, I can now control the robot in a similar way. It's just tilting at the moment, it's not walking, but the idea is, okay, so you've got your map there, select a certain place to explore, and then you can actually send the robot down to explore and such. We actually have a camera as well, but we're not going to show you that because all it shows you the camera feed. But the idea is you can show the astronaut from the space station a live feed of the robot, so you can control it like that.
We also have a sensor over here as well, which I'm going to put on my head. Hopefully it'll work.
Okay, I've only got 2 USBs, so I have to disconnect one, like Mac, unfortunately.
Right there. I'm going to put it on my head. This is the brain scanner. Scanning my brain waves. I do the brain. So the reason we're using this is when someone's controlling this robot, it's a very expensive robot and it's very tough to get it there. So we want it to be sort of like well looked after. We want it to be in a good mental state, high attention and concentration levels. So someone like me who's been awake all night doing this would not pass the threshold, so we won't be able to do it. We haven't managed to get that far, but we've got the data into LabVIEW. It's quite cool. We could take it a bit further.
Yeah.
That's okay. I'll talk about that.
You carry on, and in the meantime, you can look at
Yeah. So yeah, the camera we're using at the moment is to connect. It's just streaming stuff quite basically. We wanted to have it in LabVIEW, an all-in-one integrated thing, but it's the USBs. We couldn't manage to work around it. We didn't bring an adapter. We would like to have a 2-axis gimbal. I've made one before on my own, but I've seen that I've already done that once before. It seemed like I'd rather do something new here rather than just implement something that's pre-existing. So we could do that. Could we have a new slide, please? This is a picture of Nealesh using the brain scanner before. Early iteration, got some brain waves reading. I think these are concentration levels.
Okay, it's working now. So if he calms down a bit, it'll go quiet.
We'll go zen.
And if I shake him, it should really annoy him.
Yeah. So just pick up stuff. It's cool.
Yeah, it's cool.
I mean, it's a kid's toy really. It's 50 quid, but we're just trying to hack it and use it for something else.
The idea is if you were to use it with a glove like that, you could not only you could have the astronaut doing it, you could track their attention, and if they say they're losing attention, they can they can be warned and say no, you've got to make sure you don't do that. So yeah.
So let's do the next slide, please. And it is key features. Yeah. So just to recap, we've got a GUI here, LabVIEW interface with Google Earth on the inside. We wanted to have Mars. Google Mars exists. We couldn't make it default launch into it. Probably can do it if we go. Didn't manage it. We've got sensor data. We've got some expanding design. It's pretty easy inside LabVIEW. If you got Josh and the team, he's the man. Gesture control of the quadruped robot. It works, but the inverse kinematics is the big choke point on this. It's tough to do. It's not simple. Yeah, we can do it remotely, hypothetically. So next slide, please. So the next steps, we want to take this further. We want to have full gesture control with the library of commands we reference, really getting in there. We want to have full voice command. I did a bit of voice recognition stuff on an Android app, but because we couldn't use an Android app, can't use it, so you don't have it there. Full robotic motion would be good, different gait styles. Image tracking of the robot, that'd be nice, to have it automated, just track as the robot moves, the opposite of what I was doing. And the waypoint tracking you mentioned before, I think that's probably the best idea we've had for it. So say you're plotting a route, and maybe it's on your glove, and you just go around an obstacle and it knows how to do it, obviously. Okay, and the next one, please. So what is the application of this? Well, it's all up in the air. It's all hypothetical, but the market is emerging somewhat. We've got some players like SpaceX, Deep Space Industries, Planetary Resources. They're interested in doing mining in space, and they've got billionaire backers, so they're serious about it. Alternative applications of something like this could be in Earth-based remote mining, nuclear industries, or natural disaster zones. Maybe a spin out or a spin in. I'd like to see it happen either way. The next slide, please. The motivation for doing this project was one to rise to the challenge. It's like a marathon, staying up all night. It's quite fun. Test energies, apply our skills creatively, collaborate together. We haven't worked together in a while. We went to uni together in Manchester. It was good to see each other again. And space stuff, love it. Want to take part and have fun. And I've got one more thing for you guys. Can anyone tell me what this is? Do they recognise it?
Mars.
Yeah, very good. Next slide, please. That's what it would look like if it had some water on it. Maybe in the years gone by, maybe in the years in the future. Who knows? Okay. All right, that's the last slide.
Thank you very much.
Questions?
Yeah.
I mean, so one of the limitations with gestural technology is the lack of tactile feedback. Have you guys thought about how you're going to tackle that? Because some of the options.
If we had money, time, tactile feedback, Oculus Rift integration, all of this, we do it all, but we did the best we could in the time. But I think that's right.
I mean, you've got pager motors on here, you've got vibration, so definitely could do something like that.
I think these gentlemen were doing a SpaceGloVe and they had sort of like a conductive strip was bending. Was that how it was working?
It's a flex sensor.
Yeah, that would be. I'd like to do something like that as well. Just get all of it in and see what's best and what works well, integrate together.
They're two quite different approaches, actually.
Yeah.
I actually have a question. I'm very interested in your project. Like in our thinking, in the design, we have a problem like in the zero gravity atmospheres, gyroscope and accelerometers are not always functional properly. Do you have any kind of way to solve this problem as well? Trying to trace like you're going to trace the same way as you do while trying to.
Jimmy seems confident.
So basically, we have achieved the gesture recognition part, but we haven't achieved the communication part. So it's basically. Finish. So basically, we kind of like you train your gesture first. So you implement your gesture many times, and we use a hidden model to learn what's your gesture, and when you implement like say 10 samples and you store it, and you learn from your previous gestures, and next time and kind of like you can recognize it. So basically it's kind of an open library. If you have experience with Wii before, so it's the same sensor they have got. So basically they are a team in Germany, and they trying to implement, trying to mimic the performance of the Wii, and you can study or train your gesture and do the gesture control.
But I think in Wii, I also have discovered some background knowledge. It's also used gyroscope technologies, and mostly some of the red light sensor by changing through there is a terminal, a remote control in the Wii terminal inside, and there is a controller. They will change the distance and also the angles of the remote there. They're trying to do this way. And you mean the gesture recognition is that based on something called OpenCV technology? You're going to trace the hand motions by.
That's really good. I'll talk about it later because I've done face recognition with it. But let's get some more questions.
Sorry.
That's good. Yeah.
Basically, I think we're not trying to set a threshold to gesture recognition. We're trying to train the model, and you can train your own gesture, and you can use your glove whatever way you want.
Any more questions?
Does anyone want to wear it?
Yeah?
Go on, Sandra.
Any questions left?
I think the rovers currently are just controlled through computer terminals, right? I was wondering what are the pros and cons of using this. Would you want to use it alongside the traditional way, or do you think you could totally transfer it to just to control the rovers?
I think if there was someone, say, on Mars living there with a small communications delay, you could change it from the way what you said. But we had a bit of a nightmare with some serial Bluetooth stuff, so I'll be aware of doing that again.
The first 9 hours we didn't achieve anything. We were quite panicked about that. So we found a way in the end. But again, it's not fully what we wanted, but it's something, you know. And I think it's got potential.
And just to add an extra point to the protocol part. So basically we have tried the MQTT protocol. So you kind of like, you can subscribe to a message, a topic, and also you can post to a topic. So it's a machine-to-machine communication. So say like in this example, you can actually send a command to all your robots on Mars, something like that, and trying to communicate. It's very lightweight communication, but it's still based on wireless communication, and it can apply to wireless sensor network as well. So it can be embedded to like other sensors you want to embed to your glove. But we haven't quite managed it.
I'm not sure which one was first, but
Okay. So when you are moving your hand, you can see the Earth at a very long distance. So that's not very good for mapping a point where you want to go to. What happens when you get a closer and you are doing that movement? Is it easy to find a point on the map using that kind of simulation?
If you keep the mapping the same, it's very difficult. A little movement creates a huge movement that will move miles away. So ideally what you would do is as you would zoom in, you would kind of reduce the mapping so that that kind of movement no longer causes a rotation of 30 degrees, but maybe 2 or 3 degrees or something like that. I did actually have it zooming with light. So if you look here, there's actually audio data and light data there. So you could cover it and it would zoom in, but it was a bit unpredictable. So I took that off in the end, but do that. Answer your question.
you have a question, buddy?
Yep. The headset and attention span. Paying attention is obviously a huge deal in transport industries and heavy industry and quite a few other things. How practical do you think something like that is, and how translatable? Would it be something that you think could be applied across a lot of different fields, or is it something that's going to be so unpredictable that it's got to be like a massive rig and have a lot of computing power behind it?
Well, I mean, this one right now, totally unpredictable. It's like not really interfaced that well, but I know recently there's a move towards bringing insurance down through black box recorders and like data gathering, big data, stuff like that. So I could foresee maybe give it how many years it needs to develop this technology, maybe an application you said yes.
Okay, thank you very much.